Hello friends, today's question. The self-induced EMF of a coil is 25 volt. When the current in it is changed at a uniform rate from 10 ampere to 20 ampere in 1 second, the change in energy of the inductance is. So in this case we are going to use two formulas. One is the energy of the inductor and another one is the induced EMF. So we start with the induced EMF. So we say the EMF in the inductance which can be represented as EMF will be equal to L, and we have this as delta I upon delta T, where value of E, that is EMF, it is given as 25 volt, and the change of current, that is our delta I, will be equal to I2 minus I1, which will be 25 minus 10, giving us 15 ampere, and the time is given as 1 second. So our delta T is our 1 second. So from here, if you substitute the values, you get 25 is equal to L multiplied by 15 divided by 1. So this gives us value of inductor, that is L, will be equal to 25 upon 15, which is equal to 5 upon 3 Henry. Next, we are going to use the formula for the energy stored in the inductor. So the energy stored in the inductor it can be written as E is equal to half Li square, where L is the inductance of the coil and I is the current. L is the inductance of coil and I is the value of the current. Now in order to find out the change in energy, we can write this equation as E1 and E2, where E1 is the energy stored in inductor initially when the current is 10 ampere. So therefore we can say that the energy stored at current of 10 ampere, let us call that I1. So therefore we can write that our E1 will be equal to half L I1 square. So inductance we just found out is 5 by 3 and current is our 10 ampere, and this gives us 500 upon, so this is square, and this gives us 500 upon 6 joules. Similarly, we can find out the energy stored in inductor at the final current. Energy stored in inductor at final current, that is I2, which is our 25 ampere. So we can write our E2 will be equal to half, value of inductor is 5/3, and this is about 25 whole square, and this will be coming close to as 3125 divided by 6. We are supposed to find out difference in energy. So we can say our difference in energy, that is our delta E. It can be written as E2 minus E1. So we substitute the value, we get delta E. E2 is our 3125 divided by 6 minus 500 divided by 6, and this can be approximated as 437.5 joules. So the options that are given to us, option number A is the correct answer. So you can say option A is correct. So this completes the question. Thank you.